Hello and welcome to this tutorial. I'm sitting here outside actually because we're moving again. So soon I'm going to have my own studio again so I can record with some nice background and stuff like that. All right, I'm going to teach you how to create a Tetris game in React with hooks. This is the second version of the game. I think the first version is roughly 1.5 years old. So I modified it a bit, I tweaked it and optimized it and make it a little bit better, hopefully this time. So I think you're going to learn a lot of good stuff that you need to know to master React in this one, and it's sure going to be fun. So let's get started. All right, the first thing you have to do is to download the starter files that I provided just below this video. So go to that link and download or clone the starter files from GitHub. And I'm going to talk a little about what these starter files are, because you need those starter files to be able to complete this tutorial. And this is a setup that I created with Vite instead of Create React App that I used for the old version in this course. And we have the package JSON here. You can see that I have style components installed, and it's React, of course. And I have the types for style components and React, and also TypeScript, because this is a TypeScript tutorial. I'm going to create this Tetris game in React with TypeScript. And the most important part is inside of the SRC folder, because I provided you with some files here that we don't have to do from scratch. This one is a declaration file for the types for Vite. It's created automatically by Vite. Then I have the setup.ts, and this one has some important stuff here that we're going to use in this tutorial. And that is a const that says the stage width and the stage height, two of them here. So the stage width is set to 12 cells and the height is 20 cells. And then I have something that's called row points, and this is an array, and it has 4 different integers inside of it. So these are the points. If you clear 1 row, you get 40 points. If you clear 2 rows, you get 100 points. If you clear 3 rows, 300, and 4 rows, 1200. And these are the, if I remember correctly, the exact same points that is from the original Tetris that I looked up some time ago when I created the first version of this course. Then I created an object here with the different tetraminos. So this is an object. I have the 0. This is going to be the blank space on the grid where we have all the tetraminos. So the shape is just going to be a 0. It's nothing else, and the color is set to 0. Then we have the different shapes here, different properties in this object. And you can see the shape property here. This is the I here. That's going to create that shape. And then I have the specific color for that one. I have the J and the shape for that one. I have the L, I have the O, S, and T, and Z. So these are all the tetraminos that we're going to use in this game. So these are multidimensional arrays where I have created these different tetraminos. So we have rows and we have columns, and that's why it's a multidimensional array. All right, then I have a game helpers file, and inside of this one you can see that I import the stage width and height from the setup and also the tetraminos, because I have a function here that will create the stage for us that I export from this one also. And here I also create a multidimensional array from those values. So I have the stage height and stage width, and I fill it with an array that says 0 and clear. And I'm going to explain this more in this tutorial later, so don't worry. But essentially, the 0 means that there's no tetramino there, and clear means that there's no tetramino merge inside of the grid, because when we drop tetraminos, we want them to stay put in the grid. So we want them to be merged inside of the grid. And then we get a new tetramino and we can position that one on the grid. So that's why I have this one. But if it says clear, that means that we haven't merged any tetramino inside of that grid cell. And then I have a little helper function here that will give us a random tetramino. So what I do here is that I have this array here with all the different tetraminos except the 0 one, except the blank one. And I set it as the key of type of tetraminos. So this will give us the type. If I hover over here, you can see that I get the type here. And these are the properties from the tetraminos object that I created. So this is how you can get the type for it here. You use key of type of, and then you have the object. And it's going to be an array, so I have that as a type there. So I use the as keyword here and say that it's that type, and it will give us the type here. So that's the correct type. It can only be one of these types here. All right, then I calculate the random tetramino from the tetraminos that I create here. So that's an array, And then I math floor and math random and do some stuff here. I essentially grab a random value from the tetraminus length, the length of the array, and that will give us a random tetraminus here. And then I grab that tetraminus from the tetraminus object. So that's how I get the random tetraminus, and I return it like this. And of course, I can also have a return type here, but you can see that it gives me the return type here by itself. So I haven't specified a return type. So it will give me the return type there. I don't have to do anything here because this file, we're not going to change anything in this one. So that's why I haven't specified it more here. But of course, if you want to be more explicit, you can set the return type to be a tetraminus. All right. So that's the game helpers. Then I have the app.tsx. And this one, as you can see here, I've created some styles. I will provide you with all these styles also. They are all style components. So I create them in separate files, in a separate file that's called styles.ts. And then I import these ones inside of the component where I use them. In this specific case, it's called style Tetris wrapper and style Tetris. So it's here, we're going to have the game. And for now, it says start here. So when you start up this application, it's going to say start here. And the main TSX, I create some global styles. I'm just setting some margin and padding. And I also set a nice little background for us. And I set the background size and position and stuff like that. So we're not going to touch anything inside of this file. And in the IMG folder, I have this little nice little image that we're going to use for this version of the game. And it's kind of an autumn image because it's autumn soon. The summer has ended very soon. So I thought it was a great idea to have an image like this. Then I have a hooks folder, and this is the only hook that I provided with. And this one is created by Dan Abramov from the React team. So I just copy and paste this one in, and it's essentially a hook for creating an interval instead of using set interval that's built into JavaScript and the Typescript. We are using this hook instead, and it will create kind of a more declarative way of creating an interval. So we use this one here. I'm not going to talk more about it here because this tutorial is going to be quite long anyways. So if you check out his blog, Dan Abramov, he will have a blog post about this use interval and why we use it. But it will set up an interval for us so we can drop our nice little tetraminus in a timed interval. All right, that's the hooks folder. We're going to create, I think it's 3 more hooks later. Then I have the components folder, and you can see that I have the cell, the display, stage, and start button. We're going to create these components ourselves, but I have provided the styles for these ones. And as you can see here, I've done the exact same thing. I create them in a separate file, and then I'm going to import them in the actual component. And here I also have some props for this specific style component. And this is how you type the props with style components. You create your type, and then you have these angle brackets here, and you place your type for the props inside of there. And I've done the same here, the key of type of tetraminus, because this is the styled cell. So that's why I use that specific way of creating this type. All right. So I think that's about it. We can actually start this one up to see that it works. I type in npm run dev, and it's going to start up this dev environment for us, and it's going to be on localhost 3000. And of course, it opened up on my other monitor, but it's here. So you can see that it says here, start here, and we have this nice little image, and that means that we're good to go. So we're going to continue on in this tutorial. Okay, so the next thing we're going to do here is to create the components that we're going to use for our grid and our game. So inside the components, we're going to start with the cell component. We create a new file called cell.tsx. It's very important to have the extension tsx because we're using JSX, so it won't work with TypeScript otherwise. So first we import React from React. And I know also that you don't need to import React in some setups anymore, at least in Create React App. Here, I think you have to do it in Vite. And I don't care actually because it's only one row that I have to type out extra. So I know there's probably some of you that says, oh, we don't need to import React anymore when React 17 was released. And I know that, but I think we need to do it here actually when I have this set up now. If you want to have that setup where you don't want to do that, you have to create it yourself. So this is the way I roll in this tutorial. Okay, we're going to import the styled cell. And that is the style component inside of the styles file. It's called styled cell. So I export that one here from /cell.styles. And then we need a tetra minus from /setup. And I had this nice little auto completion here that actually typed it out for me. Then I'm going to create a type for the props for this component. So type props. I usually do it like this. I create my type for the props above the component itself, and then I use it in the component. For this one, we're going to have a prop that's called type, and it's going to be of the type key of type of tetra minus. And now we can see the specific type here. You can see that it's the same that I showed you before. It can only be of one of these types because we have the object here in the setup. This is the object here. We have the 0, I, J, L, O, S, T, Z. So these ones, when we create the types from this object here, it makes sure that we can only have these specific types. So if we send something else in, for example, a Y or something, it will complain. So that's a way to be a little bit more specific. Then we create the component cell. It's going to be a react.fc. That's how we tell TypeScript that this one is a React functional component. We have the angle brackets, and we use the props type that I created up here, equal. And we destructure out the prop that's called type. And we can do this as a one-liner because we're only returning JSX. So we don't need a return statement. We make an implicit return. So we have the style component, styled cell. We send in the type to that one type. And we also have a prop that's called color. And that color is inside of this tetra minus object. You can see that I have a property that's called color. So that's the one that we're going to grab here. So colors from the tetra minus. We have the type that we send in, and then we grab the dot color. And then we self-close this component. It's a little bit tricky here now because I have bumped up the font size, but it is on one row, so you can see it here. Hopefully you can see everything. Then we need to export default. And I'm actually going to wrap this one in a react.memo. And why do I do that? That is because when we render this grid, if we have this cell, each cell in a React memo, that means that we're only going to render those cells that actually change. Otherwise, it will re-render all of the cells, and we don't need to do that. So we can put this one wrapped inside of a React memo, and it will make sure that it will only change the cells that actually changed, and that will be our tetra minus that is moving. All right, so that's everything there is for this component. Let's move on to the next one. It's going to be the display component. We create a new file, display.tsx. We do the same, import React from React. And I import the styled display from the style file, just as before. /display.styles. And we have some props for this one also. So I do the same here, type props. You can name them to whatever you want. It doesn't need to be named props. We have a prop that's called game over. And this one is going to be optional, so I can mark it with a question mark. And it's going to be a Boolean. And that is because I want this display to be used both for the game over display and also for the display with the different rows, score, and stuff like that. We have another prop that's called text, and it's going to be a string. Not string constructor, it's going to be a string. Right, that's the prop. Then we have a const display. And it's also going to be a react.fc. We have the angle brackets and our props equal. I destructure out the game over prop and the text prop for this one. And we can also make an implicit return on this one since we're only returning JSX. So we have the style display style component. We send in the game over prop to that one. Because as you can see here in the style file, I have this prop also game over. So I changed the color here depending on that prop. And that's what's super great about style component, because you can make dynamic CSS depending on different props and stuff. So if we set the prop that's called game over to true, I'm going to set the color to red. Otherwise, it's the 999 color. Right, back to the display.tsx. We close it. And then we have curly brackets, and we're going to display the text. And yet again, it's a little bit bad here because I can't show the whole row here. But hopefully you can see how I've done it here. So I have the style display, I send in the game over, I close it here. We type out the text, and I close the style display here like this. So this is pretty basic stuff in React. And this is, so I think it's considered at least an intermediate, but probably an advanced tutorial. So you should know some stuff about React. We need to export default display. Right? That's the display component. We have the stage component. Yet again, create a new file called stage.tsx. We import React from React. And now we're also going to import the cell component that we created. So import cell from /cell/cell. And then we import the styled stage from /stage styles. This one also have some props. So type props equal. We have a stage prop that is going to be of the type. We're actually going to create that type later in a hook that we call useStage. So I don't have that type here. So what we can do for now is to either we can create it here instead. Maybe we can do that. Yeah, I'm going to create it here instead. So I create a type stage cell equal. It's going to be a tuple string. It can be of the value. It can be of the type string or number. So this is the first value in the stage cell. And then we have the second value, and that one is going to be a string. So the first value can be either of the type string or a number, and the second value can be of the type string. And then I create another type that I call stage equal. It's going to be the stage cell. That's of course the one that we created here, and it's going to be a multidimensional array. So we have a dual array like this, and that's the stage. So we can set the type here to stage for the props. So that's how you create these types for the stage. We can actually export them also, and we don't have to recreate them later. So we can import them from this file instead. Right, then we create the component const stage : react.fc angle brackets, and we have the props equal. We destructure out the stage. We make an implicit return, but on different rows this time. So we have parentheses. We use the styled stage style component, and inside of that one, we're going to map through our stage, because this prop that we send in here is the complete stage. And as this is the stage component, it's going to render out some cells. So we're going to map through this stage. Stage.map. We have the row. Then we map again, because this is a multidimensional array. And then we get a cell. We also need an X value on this one, because we're on the row, so I call it an X. You could also call it I or something if you want to do that instead. And of course, I also need to wrap them in a parenthesis like that. Something like that, I think. And for each cell that we map through, we're going to render out the cell component. We give it a key of X. That's fine to use the index here as a key. And the type is going to be the cell 0. We also have to close it here. All right, so it's complaining here now. Type string number is not assignable to type. Okay, so we have to be more specific here, actually, with the type. So instead of doing like this, we're going to import tetra minus from setup. It auto-completed here. So import tetra minus from .. .. setup. Instead of doing like this, key of type of tetra minus. And that will make that one go away, because now we are more specific here. You can see that we set the cell that it can only be one of those values. And that's great with TypeScript, because now it complained and telling us that, yeah, you can actually send in something else here, because in the cell component, we specify that it can only be of this type here. So we need to be consistent and also have that type here. Otherwise, it will complain. So that's the more correct type here. Great. All right, then we need to export default stage. All right, one more component to go. Save this one. And that's the start button. Create a new file, start button.tsx. And we import React from React. And then we import styled start button from ../start button.styles. And we have a prop for this one, type props equal. And it's going to be the callback for the button. And this one is a callback, so it's a function with no parameter that returns nothing. So we set the return type to void. And then we have the const start button. It's a react.fc, a functional component. We have the angle bracket and our props. Like this, with the structure out the prop, the callback. And we make an implicit return, but we have parentheses. I think it will be a little bit long otherwise. The style start button. We have the on-click handler on this one. It's going to be the callback. And it's going to say start game. Like this. And then we export default start button. There you have it. 4 quite basic components that we're going to use inside of our app component. So go inside of the app.tsx. And we're going to create our grid. So we have the styles somewhere up here. We can have our components. So import stage from ./components/stage/stage. And then we import display from ./components/display. /display again, and the last one is going to be the start button, and we input that one from components /start button /start button, like this. And we're not going to import the cell here, because that's the one that we only use it inside of the stage, so we don't need to import it here. And now we can restructure this little JSX down here. So we have the style Tetris wrapper, and we can remove inside of the style Tetris, remove star here. Then we create a div with a class name of display. So this is going to be the display on top. And I don't always create style components, because in this case, I don't think we need it. Sometimes I use class name and I style it with a regular class name. So you can see here inside of the one here, I have a class name that's called display inside of the style Tetris style component. So that's fine to actually mix them together. First, we're going to check if we're in a game over state. And I have a ternary operator. We haven't created that state yet. Going to do that in a second. And we have a fragment. Then we use our display component. We give it the game over prop of game over. And the text is going to be game over. And we self-close it. Then we're going to have the start button. And we have the callback for that one. That's going to be a function that's called start game. But we haven't created that yet, so I'm actually just going to give it a function that says null for now. That actually returns null for now. All right, so that's the first part of the ternary operator. Then we have the colon, and we have the second part. If we're not in a game over state, we have a new React fragment. And we're going to return a display with the text that says score. And that is going to be fine for now. We're going to have these variables here later. So we can actually already now create backticks here instead so that we can merge them in to this one. Save, close it. And we can take this one here, copy, and paste it in 2 times. And we can change the text here, score. It's going to be rows. And then we have level. So that should be it, I think. We need to create this game over state. So move up here to the top of the component. We're going to have 2 states here inside of this component, and it's going to be the drop time and the game over. So we can create a drop time also. Drop time set drop time equal react.useStage. You can import these ones up here if you want to do that also, but I like to do it like this nowadays. So that's how I do it. You can do whatever you want. I'm going to set this one to null. And this one can actually be a number also. So we have to specify the type, and we do that as a generic inside of these angle brackets. So we specify it as null or number like this. That's the first state. Then we have the const and the game over state, and set game over equal react.useStage. And this one we can set to true because we want to kind of start off in a game over state. Otherwise we won't see the start button here because I placed it inside of that one. So that means also that this one we don't need to type it anymore because it's a boolean and it's set to true. So it will interpret it as a boolean. But in that case, if we set that one to null and it can be a number later, it means that it can't interpret it itself. So we have to tell it specifically that it can be null or a number. And that is because we're going to use this to the interval that we're going to use to drop the tetraminus. And when we set that interval to null, we stop that interval. Otherwise, it's a number. All right. And the last thing here is the stage that we need. So we have that component, stage, and it takes in a prop, stage, like this. And we haven't created that stage actually, so we need to do something kind of special here to make it work before we have created that. We're going to create the stage in a custom hook later. So for now, import create stage from /game helpers. And that's the little one that I showed you before that I created that will generate this stage for us. So we can call this function down here instead. For now, create stage, save it. Make sure to save all the files. Move back to the application, and you can see that we have our nice little stage here. This one, of course, won't work. Just going to make sure so I don't have any console logs here. Yeah, failed to load resource. I don't know what that resource is. It must have been something that was left from before or something. Because we have the grid here and it works. And in the last version, I actually had a responsive grid, but I didn't think it worked that well. This one is only made for screens, desktops, as far as it is now. So if you want to use it on mobile devices, you have to create those buttons also somehow, because we're going to use the buttons on the keyboard. So you have to visually also represent them if you're going to use it on a mobile phone. But I won't go through that here. I want to focus on creating an actual working Tetris game on the desktop. We have our grid to the Tetris game, and we're going to continue on to creating a couple of hooks that we're going to use for the player and the stage. So move back inside of the code, and creating custom hooks in React are usually if you want to have some code that you can share the logic to different components, or it can simply be if you want to break something out and don't have everything inside of the same component. For example, in this case, I'm going to use it mostly because I want to break that code out and isolate it in its own hook. So it's not for reusing it probably, because this is going to be very specific to this Tetris game. But you can select to have all the code inside of the app component itself. The app is the heart of this game. So it's kind of the game engine, so to say. But I want to break them out in different custom hooks. And also I want this video, this tutorial, to be more of a practice on how to use React and hooks and TypeScript with React, then actually create a full-blown optimized Tetris game. So inside of our hooks folder, we're going to create a couple of more hooks. So first, we create a file that's called usePlayer.ts. You should name all your hooks with use before you have the name. That's a way for React to tell that this is a custom hook, and it will treat it that way. So usePlayer.ts, that's the file. So we're going to start with the player, then we're going to create the useStage file and the useStage hook also. But let's start with the player. So we're going to do some imports here. First, we're going to need the stage with from /setup. Then we're going to import random tetramino from /gamehelpers. So that's it for now. We're going to do some more stuff here later. The first thing we can do is to create a type for our player. So we export type player, capital letters, equal. You can, of course, also make this an interface if you want. I usually use type instead of an interface, but it doesn't matter in our case. And they are very, very similar today. So you can use either type or an interface. So this one is going to be an object that has a pos property. The pos is going to be the position. So inside that, it's an object 2. We have the x, that's going to be a number. And we have y is also going to be a number. Then we have the tetramino, that is going to be the current shape that we have on the play field. And that one can be either a string or a number. And it's going to be a multidimensional array. So we have 2 of them here. And then we're going to have a prop that is named collided. And it's going to be a Boolean. So this one is going to tell us if we collide with something on the play field. And then we set this to true. And then we know that we collided. So this one is always going to be, so to say, one step ahead. We first check everything. And we're going to set this to collided if we're going to collide later. And then we know that we collide if we move to that stage. So we're not going to move there. And we're going to do some stuff if we collide instead. All right, so that's the type. Then we have the hook itself. Export const usePlayer equal an arrow function. First, we're going to have some state to keep the player in. Player and set player equal react.useStage. And for now, we're going to set it as an empty object, but we can say that it should be as a player type. So as player. Yeah, and of course, we also need to import React from React like this. Then for now, we're going to create 2 different functions. One is going to be called const update player pos. And it's going to take in an object, and we can destructure out the different properties from the object. We're going to have x, y, and we're also going to have collided. It's going to be an arrow function. We'll make an explicit return. And this one, we can specify the type for. And of course, we need an equal sign because this is an arrow function. And when we specify the type, when we destructure out these properties, we have a colon, and then we have another object, another type object here, so to say. And we have x, it's going to be a number. We have y, it's going to be a number. And collided, it's going to be a Boolean. So a little bit long here, but I think we'll be fine. So these are the properties that we destructure out from the object that we can send into this update player pos. And then we specify the type here for that function. We can also specify that we won't return anything. So we specify the return type as void. And the only thing we're going to do inside of this one is to set a new player. So we have the setter for that state because we have the player in the state. So set player, we have the previous state, an inline arrow function, and I'm going to make an implicit return, and I'm going to return an object with the new player position and stuff. So I need to have parentheses when I return an object. So parentheses and curly brackets. Then I'm going to spread out the old player properties. We set the new position. It's going to be an object. X is going to be from the previous pos.x plus equal sign x. So we add in the x value, the new value that we send in here to the player position. We have the y value. It's going to be from the previous pos.y plus equal y. We also add in y. Then we have a comma and we have the next property and we set the collided. And this one has the same name as the property and the object, so we don't need to specify it like this, as it has the same name and this is ES6 syntax. We can specify it like that. Do some auto formatting and it wanted some parentheses here. That's fine. So this is the update player position. Then we need something to reset the player also. So const reset player. And this one is going to be sent into the stage later, to the stage hook. That is why we need to wrap this one in a use callback, because otherwise we will go into an infinity loop. So from React, we have the use callback, and this will make sure that this one won't be recreated on each render. Otherwise, yeah, that's what's causing the infinite loop that we're going to get, because it will recreate this on each render. And you could also have this use callback on all your functions and callbacks and stuff like that. There's nothing wrong with that. There's a lot of people that do that, but I don't tend to optimize stuff if I don't need to. This application won't be slow, so we don't need to have this cluttering the code all over. So we have our function. It's going to return void, and it's an arrow function. We set the player again, because now we reset the player. And this time we don't need the previous state. We're going to set the position. X is going to be the stage with divided by 2 minus 2. So this is very specific numbers that I tried out because I want the position to be roughly in the middle of the play field. So this is something that you can improve. You can put these ones in some, maybe in the setup file or something, so you can change it more dynamically if you want to do that. We set the y to 0. We want the player to start at the top of the play field. We have a comma. The tetraminor. From the random tetraminor, we're going to call that one, and we're going to grab the shape. So this random tetraminor will create a random tetraminor, and then we grab the shape property, because we only need a shape to go inside of this tetraminor property. And we set collided to false. Like that. And here we should have a comma. And we have an empty array, because we only want to create this once. So these are the two functions that we're going to create for now for the player. One function to update the position of the player, so we can send in the new coordinates and if the player has collided. And we also have a function that's called reset player, where we can reset the player to be on when we restart the game. So from this one, we return an object with the player, the update player pos, reset player, and also later we're going to have a rotation function for the player. But for now, this is fine. So this is the usePlayer hook for now. So before we import and use this one, we're going to also create a useStage hook. So inside the hooks folder, create a new file that's called useStage.ts. And we do roughly the same here. We import some stuff here at the top. Import React from React. We're going to import create stage from /game helpers. We want to be able to create a new stage. And we also need a player type. So import. And when we import types, you can also specify it like this with type. And then it's easy to see that it's a type that you import from /usePlayer. So you don't really need this one if you don't want, but I think it can be good to be a little bit more explicit sometimes so that you clearly see that this is a type that you import. And then we're going to create some new types here. Export stage cell. Yeah, this should also be a type, of course. And each stage cell is going to be an array that can either be a string or a number. And the last element in the array can be only a string. So we have two elements in this array. One that can be a string or a number. And this is because here, if we look in the game helpers where we create a stage, we're going to have an array with arrays. And this array has two elements. The first one tells us if it's a tetraminor, a letter for the corresponding to each tetraminor, or if it's 0, it means that it's empty. So there's nothing there in that cell. And then we have this property that tells if we have collided with that cell before, so we merged in that tetraminor, or if it's clear. So that's why this is a string, and this can be a string or a number. Go back to the useStage. We can also export a type called stage only. And that one is going to be a multidimensional array with the stage cell like this. So that's the types. Then we export const useStage equal. This one is going to take in the player and it's going to be of the type player. It's also going to receive the reset player function. And that's why I created a use callback around this one here, because we're going to kind of pass this on to the useStage. And that means that when this will be recreated on each render, this useStage will go into an infinity loop. So that's why we wrap it in a use callback. And this one is going to be of the type an empty function that returns nothing, so void. And then we have the hook itself here. So first we need a state, const stage, set stage, just as we did in the player hook. React.useStage, state, not stage. And we are going to call this create stage here initially. So we create that stage initially in this state. And we want the stage to update on each render. So we can use a React use effect. We have an empty arrow function, curly brackets. And this one is going to have a dependency array that we're going to fill in here when we have everything we need here. So first we're going to check if we don't have a player position, we simply return, we don't do nothing. We need to have a player position to be able to do something. Because when we initialize the player from the beginning, this one is an empty object, so it will break if we don't return. You could do this in another way also, and you can create a real initial state. And then we don't need this one probably here. But it's always good to have this kind of safety in your code so that we know that if we don't have a position, it will just return we don't do anything because we don't have a player, so we can't do anything really. So then we're going to create a function here inside of the use effect, const update stage. This one is going to take in the previous stage. It's going to be of the type stage. And then it's going to return a new stage for us. So that's the update stage. And then we're going to do some stuff inside of the little function here. Now it complains because we're not return a stage. So yet again, you can see Typescript always tells you if there's something wrong. So first, flush the stage. We want to clear the stage first so that we remove any trails from the tetraminor. Otherwise, we just build on the previous render and it will be a trail from the player tetraminor, and we don't want that. So we want to flush the stage. We want to clear the stage. So if it says clear, but don't have a 0, so it's that array that we created here. If this one says clear, but it don't have a 0 here, that means that it's the player position that we're on now. So it means that it's the player's move and should be cleared. So we want to clear that before we make another move, otherwise we'll get that trail. So I have a const, call it new stage equal prevStage.map. We have a row, we map through the row, and this is a multi-dimensional array. We also have to map through the row, and this will give us a cell. And we want to set this new cell, so we have to do a turner operator here to check what values we should give this cell. So cell, if cell 1, it's that value up here that we're checking for now. If that one equals to clear, then we're going to return a new cell with 0 and clear. So this means that it can be clear, but it can have another value here because it's the current tetramino that the player is playing with. So it could, for example, have an I here, and that means that we clear it and set it to 0 because then we move to the next stage. So this one should be clear. If this one says merged, we know that there should be a tetramino that is merged, that the player previously collided there. But in this case, we're just resetting everything because we moved to the next stage. So otherwise, we just return the cell. And we can also cast this as a stage cell, like this. We have some error. prevStage map row. Yeah, this parenthesis shouldn't be here. It should be here instead. Like that. So very, very easy to make a mistake here with the parenthesis. We should have one around this map here, the green one. Then we have a red around this one. It wants to have a little parenthesis here because I had that turner operator. And then we cast everything as a stage cell array. Very important. All right, so we have a new stage. We have a cleared stage with all the merged in tetraminos as they should, but we clear the current position of the player's tetramino. Then draw the tetramino. So now we want to draw the new move on the stage, and we do that by looping through the player, and we get the player here because when we call this hook, we send in the player. So we have the player. So player dot, and from the property tetramino, we're going to do a for each loop. And I know that it will be faster to have a regular for loop, for example, but it doesn't matter in this case, I think, because it's not a very heavy game. So we're going to have the row and the y value, the y iterator. So it's a little bit nested here, but it's always like this when you create games. You have to have nested loops when you have a multi-dimensional array and stuff like that. So this is where it gets a little bit advanced. We have another for each loop inside of that one. And we have the value and the x. We'll probably also call this cell. And we have another arrow function and curly brackets. And then we can do something inside of here. So first we check if value not is 0. Yeah, it should probably be called value because it's not a cell. So we have the new stage. We grab the first position, y plus player.pos.y. Then we have another value here, x plus player.posx, and this will grab the correct cell in the stage, equal. So we set the new value here on that position. We have the value, then we have a template literal, we have a $, and we grab the value inside of curly brackets, player.collided. So if the player has collided, we're going to specify it as merged. Otherwise, it says clear. So if we have collided, we're going to merge in this tetramino, and we do that by specifying this cell as merged. And this is everything we have to do for now in this update stage function. So first we flush the stage, we clear it, so we have a clean stage to work with. Then we loop through the tetramino that the player currently is playing with. So we have the row and then we have the value for that tetramino. And when we loop through the tetramino, we check if the value isn't 0. And we can see here in the setup. So this is a tetramino. If it's 0, it means that it's empty in this current shape. Then we move to the next. And this one is an I. So that's not empty, but all the others here are empty. And this will create this shape here. So that's what we're doing here. We loop through, and when it's not 0, we know that we're on a cell in this current tetromino. That is, we're on a cell that is included in the shape for this tetromino. So bear in mind that this is the tetromino that we loop through here, but we are updating the stage with these different positions. So we loop through the tetromino, but we're updating the stage array. And if the player is marked as collided, we set these cells on the stage as merged, and that will make that tetromino stay in the stage. You can see I don't have the rules of hook turned on here somehow. I don't know why, but this is the dependency array for this use effect. So we're going to specify some stuff here to make this work correctly. We have the player collided. We have the player.pos.x. And this one may be that it doesn't exist. So we can have a question mark in TypeScript to make an optional chaining, as it's called. So if this doesn't exist, it will return undefined. And then we have the player.pos y with a question mark also. We have the player.tetromino. So this will do for now. These are all the dependencies here for this one. We actually also need to return inside of this update stage function. You can see that it complains. We of course also need to return the new stage. And that will make that go away because we're returning the new stage. And to use this function here now, we're going to set the stage. We have the previous value and we give that value to the update stage function. Prev, like that. So this stage will be set depending on this function here. All right, so that's the player and the stage as we have them now. We're going to fill in some more information and code here later. But for now, this is enough. And in the next part, we're going to use these custom hooks and actually draw something on the stage. Okay, we created the custom hooks for the player and the stage. And now we're going to be in the app.tsx file and use these hooks. So the first thing we do here is to actually import the hooks. So I mark them with custom hooks. Import. We're also going to import the useInval hook, the one that I provided for you. From ./hooks useInval. Then we're going to import the usePlayer hook. From ./hooks usePlayer. And then we import the useStage hook from ./hooks useStage. And now we can use the hooks here in our component. The const, and we destructure out the player, the update player pos. These ones needs to be named the exact same name as we had because we're destructuring these ones out from the object that we return from the hook. And we have the reset player equal. We call the usePlayer hook, and this one don't get any arguments. So that's the player. Const. We destructure out the stage. Set stage. Yeah, that's actually enough for now. Then we call the useStage, and this one needs the player and also the reset player. Yeah, we haven't actually. I guess we haven't returned these ones. No, we haven't returned them from the hook. So that's, of course, something we need to do. Just below this one here, we return stage and set stage from the hook. And that will make that error go away. But here you can see that this reset player is passed along to this useStage. And yet again, that's why I wrap this one in a React use callback, so it won't be recreated on each render because it will cause an infinity loop. All right, so that's the hooks. Then we need some functions here in our app component. We have a function that's called movePlayer. So I'm just going to scaffold out these ones for now. Yeah, and of course we need an equal sign, and this one is going to have an argument. Direction, it's going to be a number, so we can tell the direction on where we want to move the player. And we have this update player pos here. We call this one update player pos. And it takes in an object with the x value. X is going to be the direction. Y is going to be 0. Because we're not moving down here, we're just moving to the sides. Down is going to be automatically dropping down. And that's what we're going to use that use interval hook for. Collided is going to be false for now. So that's the move player. Then we can create a function called move. And this one is going to be an event. And from the event, we have something that's called a key code. So I structure out that. We also need something that's called repeat. That is going to be a boolean that tells us if the key is hold and it's repeating, it's auto repeating. This one is going to be set to true. So the first time you press on the key, it's going to be set to false. We can also specify the types here. The key code is going to be of the type number, and repeat is going to be boolean. We're going to return void from this one, and it's going to be an arrow function like this. So here, if not game over, let's see, we set that one to, yeah, it's true. We can actually skip this one for now. We're going to wrap it in that one later. So first we check if key code equals 37. This is going to be the left arrow on the keyboard. So if that's the key code, we're going to move player, and we specify that's -1 because we're moving to the left. So that's -1 on the x-axis. Else if key code equals 39, that's going to be to the right. We're going to move the player and give it the value 1 because we move to the next position on the x-axis. Else if key code equals 40, that's going to be the down arrow on the keyboard. But we just want to call this once because we are going to check if repeat. If we're repeating, we just return. We don't want this tetromino to move by a lot of auto repeating keystrokes on the keyboard. So that's why I don't do anything here, because we are going to set the drop time to 30 and control this ourselves. We're going to increase the drop time so that the player can press the down arrow and the tetromino is going to fall very fast down to the bottom of the grid. All right, I'm going to show you this in a second. Else if key code equals 38, that's going to be the up arrow, and we're going to use this one to rotate the tetromino. So in this game, I'm only using one direction on rotation. You can make this a little challenge yourself and create rotation in 2 different directions. But this one is only going to go forward. And we're going to implement this later because we haven't done the rotation yet. So what we're going to do here also is on this style Tetris wrapper, if we check here on the game, this is, I have a wrapper around this one. This is where we're going to have the key events. On key down, we have the event and we pass it along to the move function. So that's the ones that we structure out from the event here in the move function. I'm going to scroll up a bit. Then we have on key up. Then we're going to call a function that's called key up, and we haven't created this one yet. And we need a ref on this one also, and I'm going to tell you why in a little while. And we're going to create a ref that's called game area. We can actually do that now. I move up here. We can create the ref maybe here. Const game area equal react.useRef. And this is TypeScript, so we have to specify the type HTML div element. And we set it to null because this one isn't going to have a value on the first render, so it's going to be null, and then it's going to have the correct value. So you can see that this one won't complain, but we have a key up function that we need to create. We can maybe create it here. Const key up equal And from the event, we're going to destructure out the key code. And I just realized I don't think we need to do it like this. We can just specify move here. And it should work because it will pass along the event to this one. It will call the move and key up with the event. Right, we're going to specify type also for this key code. Key code is going to be of the type number. And we return nothing. So we specify the return type to void. Then we can do something here. This one is going to be triggered when the user releases the key. And later we're also going to check if the game is over. But for now, we change the drop time speed when the user releases down arrow. So if key code equals 40, that's the down arrow again. We set the drop time to 1000 divided by level. And this is also something that I done by trial and error. And the level, we actually don't have that right now. I'm just going to set the drop time to 1000. That one is going to be in the useStatus hook that we're going to create. So we just set the drop time to 1000. I think that's the one that we specified. Did we even specify it? It's actually set to null. All right, we're going to do that when we create the start button function that we're going to have now. This is a callback for that button. Const handle start game. Going to be an arrow function. It returns void. So the first thing we have to do here is to need to focus the window with the key event. With the key events on start. And this is why I use this ref down here, because I need to set the focus on this one. Otherwise, when you click the start button, the focus will disappear from the game area and you won't be able to use the key arrows to control the tetromino and do anything related to the key press, because it will take away the focus, so it won't work. So you have to click on the game itself, on the grid itself for the game here for it to work. And we don't want to do that. So I'm going to focus this one automatically. So if game area.current, if we have a game, if this ref is set, which it should be, game area.current, we're going to run the focus on that one, and that will focus it again when we click the start button. Then we reset everything. Set stage. We're going to create a new stage. So we create an empty stage. Set drop time. And here we can set it to 1000. And you can have this in a const also if you want somewhere, so you don't need to change it in all of the places of the code here. So I realized I maybe should have done that. And maybe I should do that. No, we can keep it for this, but you can refactor this out and put it in the setup or something here instead. Then we reset the player. Then we're also going to set the score level and rows, and also set game over is going to be false when we click the start button. All right. So this handle start game is going to go on the button. Where do we have that button? Start button. It's this one here. Start game. Called handle start game. So we're going to utilize this use interval hook now, and we can create it. Yeah, it doesn't really matter. We can create it here last. Use interval, an empty arrow function, and then we're going to create a function that's called drop. And this one, take the drop time as the second argument. And then just above it, we can have the drop, const drop equal function that will return void. And the only thing we're going to do for now is to update the player position. We give the X value 0, Y 1 because we're moving down 1, and collided is going to be set to false for now. So this drop function is going to be called from the interval, and that will hopefully create some game here for us so that we see something, but no, we don't see anything here. And that's a little bit unfortunate because we should see the tetraminor. Yeah, we're not actually passing in the stage here, so that's why. To change this one here at row 88 in my code, we of course need to pass in the stage because we were only creating the stage just as we did before, but we moved everything to that hook now. So click start game, and here you can see we have the tetraminor, but we can't collide with anything, of course, so it won't work now. And when we leave the stage, it will break. Just going to reload it a few times so you can see that we get a different tetraminor now. That tetraminor, because we are grabbing a random tetraminor. So our controls to the left and right work, but we can't collide and we can't really rotate or do anything. And you can see that it drops also. The interval is working. And when we go down here, it will break, but that's fine. So that's it for now. In the next part, we're going to do some collision detection with the player. And then we're going to move on to make the player rotation and stuff like that. All right, we have a moving tetraminor, and it will randomly give us a tetraminor also. So we're going to have to start thinking about some collision. And that's the first thing we're going to do in this part. We're going to create a function for us to do a collision detection. So move inside of the game helpers file, just below the random tetraminor function. We're going to export this function so we can use it in the other components. Export const is colliding equal. And this one is going to take in some arguments. So first, it needs the player. We need the player to be able to check if the player collide. And it's going to be of the type player. We need to import that type also. Yeah, it auto imported it for me here. It's from the hooks and the usePlayer. Stage. And the stage, we actually have the type stage. And it also imported it here from the hooks, the useStage. So that's the one. And then we're going to have an object with the movements. So it's going to be X. And we can actually rename this one to move X. And Y, it's going to be move Y. Because we are going to have some for loops here where I use the X and Y. So that's why I rename them now. And we can have the type for this one's X is going to be a number, Y is going to be a number also. And this is going to be an arrow function like this. I can actually make a little comment here using for loops to be able to return and break. Not possible with for each. So that's why I use for loops now, because it makes no sense to continue on the loop if we already found out that it will collide. So we have a for loop. Let Y equal 0. And Y should be less than player.tetraminor.length. So we're looping through the tetraminor here. And Y plus equal sign Y. Plus equal sign 1. I rarely do this for loop, so I'm not used to it anymore. So that's the first loop. Then we need to have a nested loop because this is a multidimensional array. So let X equal 0. And X should be less than player.tetraminor Y.length. And X is going to be plus equal 1. And that will be these loops, I think. Yeah. So first, I'm going to make a comment. 1. Check that we're on an actual tetraminor cell. So if player.tetraminor, and we use these values, Y and X, y x not equal 0. Yet again, we check so that we're really on the shape here, so to say. So we look in the setup here. As I told you before, we need to be on a character here, not a 0. That's part of the shape of that tetramino. So that's what we're checking for here. Then we have another if statement, and here are all the collision checks going to go. So I'm going to comment this. Check that our move is inside the game area, the game area's height, y, that we're not moving through the bottom of the stage or the grid. Right? So if not stage y plus player.pos.y plus move y, we add the new y movement. So that's why I renamed them up here, because I use x and y here. So that's the first check. Double pipe. We're also going to check 3. Check that our move is inside the game areas with x. If not stage, y plus player.pos.y plus move y. And then we grab the x position here plus player pos plus x plus move x. So this will take care of that. Then we need also to do one more check here. So double pipe for, scroll this a bit. Check that the cell we're moving to isn't set to clear. Because if it's set to clear, it means that we're not colliding. Stage y plus player.pos.y plus move y. And then we have x plus player.pos.x plus move x. Then we grab the first value in that cell array, because that's still the value that we have. Where do we have it? Was it there? Yeah, here, up where we create a stage. It's this value that we're checking for in the cell on the stage. If that one isn't clear, then we know that we're colliding. That's everything we need to check. So we have curly brackets here, and we return true. We know that we're colliding. And 5, if everything above everything above is false, we return false. So that means that we're not colliding. So first we check if we're on an actual tetramino cell, because we're looping through the tetramino. And then we check that our move is inside the game area's height, so that we don't fall below the bottom. And we do that by checking that we really have this position on the stage. Then we check it on the x coordinate so that we're inside of this grid area. And then we check so we're not moved to a clear cell, because that means that we're not colliding. This one has to be marked with merged. Then we know that we're colliding. A little bit tricky here, but this is usually like this in game development. I noticed I'm not a game developer in any way. I just like to make this kind of small games and try different stuff in React. All right. So that's our collision detection function. And we're going to move inside the app.tsx file and use it there. Up here where we import create stage, we import is colliding. And first in the move player, before we do any move here, we're going to check if not is colliding. And we're going to send in the player, the stage, and also an object with the x position that is going to be the direction and the y is going to be 0 because we're moving sideways. And we wrap this one inside of here. So if we're not colliding, we're going to make the move. Otherwise, we're colliding, so we're not making any move. And also inside of our drop function, instead of just moving it here, we're going to do almost the same here. If not is colliding, we send in the player, the stage, and the object with the new position. So x is going to be 0 because now we're moving down. So y is going to be 1 step down. And we can also do some more stuff here, meaning that if we're colliding, we have an else statement here. We can mark it with game over. If player.post.y is less than 1, we know that we're leaving the stage at the bottom. We console log game over. And we set the game over to true. And set drop time to null. We stop the interval. And then we're going to update the player position. We set x 0. We set y to 0. And we set collided to true. So we mark this player as collided. And the game is over. And I think this should be it. Save all the files and go back to the application. Reload it just in case. Start. And you can see that we can't actually leave this grid now. That's good. And if we go down here, it will collide. Nothing happens now, but the game has stopped. We have a fully working collision. So that's sweet. It's starting to look like something here now. And in the next part, we're going to talk about rotation and implement that for the player. Okay, time to think about rotation. So that's what we're going to do in this part. So move back to the code, and inside of the usePlayer hook, we're going to implement the rotation. So somewhere, maybe up here, const player rotate equal. We're going to send in the stage to this one, and it's going to be of the type stage void. And we're actually not importing the stage. So I import it from the useStage hook. So the first thing I want to do is to make a clone of the current player. I don't want to modify the one that's in state right now. So const cloned player. You shouldn't ever modify the state directly. So if we want to deep clone this object here, we can do that by JSON parse and JSON.stringify the player. So that will make a deep clone out of it, and it will work for us. Then we have the cloned player, not console log, cloned player dot tetramino. It's going to rotate, and we give it the cloned player dot tetramino. So I'm going to modify this one in place here, the clone player. And we haven't created this one, so I'm going to create another function here, const rotate. And this is just to split it up a little bit so it looks a little bit cleaner. So I'm going to call it the matrix. And it's going to be of the type player and tetramino. So I grab only this property on the type player here, and this will give us this type here. Right. So first, make the rows to become calls. We transpose it. The const matrix mtrx matrix dot map. We have the value. We're not actually going to use that, so I only use an underscore here. We need the index, the I. and matrix.map, because this is a multidimensional array. Again, we have the column, and we return the column the column index I. So this will make the rows to become calls, then reverse each row to get a rotated matrix. So we return the mtrx.map. We have the row, and we run row reverse. That's the built-in reverse method. So this will rotate the matrix, and the matrix is the tetramino in this particular case. So for now, we can just set player with the clone player. So this player rotate, we need to export this one here also. Player rotate, like this. Save this hook, go back to the app.tsx file, and up here, where we destructure out stuff from the player, we're also going to destructure out player rotate. And down here in our move function, we have this little comment here, implement this later, and we're going to implement this now, player rotate, and we give it the stage. And we're not actually doing anything with the stage right now, but we are going to do that in a second. We're just going to make sure that this works. So go back to the game, start, and you can see if I click the up arrow, it will rotate. But we have a little problem here. If we rotate, for example, here at the wall, you can see now it's locked here. It can rotate inside of the wall, and that will make it collide. So that's no good. It will break here, as you can see. So we have to take this into consideration. So that's why we're going to implement this also in the usePlayer. So up here in the player rotate function. So before we set the player, this one is so the player can't rotate into the walls or other tetraminos that's merged. All right, so this is a little bit tricky here actually, and it's actually quite hard to explain also. And I have to admit that I found this somewhere on the internet, and it's been a while since I looked at it. So let's see how this goes. So first I have a const where I save the position x, cloned player.pos.x. So this is just for saving that one. Then we have a let with the offset. It's going to start at 1. So we're going to modify this here. So that's why it's a let and not a const. Then we have a while loop, while, and we use this isColliding function. We have the clone player, the stage, and the object x0 and y0. We're not moving anywhere now. We're staying in place. We're just rotating. And this is colliding. I don't know if it auto-imported it or if we had it since before. I don't remember. If you need to import it, you have it in the game helpers. So import it from there. All right. So while we are colliding, we have to do something, because if we're colliding, when we rotate, we need to move this tetramino away from the object that we're colliding with. So the cloned player.pos.x is going to be plus equal the offset, and it starts at 1. And the offset, we set this to minus, we have parenthesis, the offset plus another parenthesis, we have the offset. If this one is greater than 0, we set it to 1. Otherwise, we set it to -1. So we're constantly changing the offset to kind of give it a little bit trial and error here to see if we collide with anything. And then we move the player away 1 step in the X direction to see if we can rotate there instead. So if offset is greater than cloned player dot tetramino 0 dot length, and this is because I can use the first element here because I want the length of each row, and they are all the same length. So that's why I can grab the first element here to get the length. We're going to set the clone player.pos.x to equal posx. And then we return. So this is what we have to do this little kind of extra check here, so that we cannot rotate inside the walls or inside another tetromino. Save the file, go back, start game, and we can try this. You can see that it constantly moves out from the wall when we rotate, so that we can't rotate inside of the wall. That's exactly what we're looking for. So you have to play around with this if you want to understand it more deeply. It's quite complex to explain this one here. So try it out if you don't understand how it works, and try to change the values and see what happens. In the next part, we're going to do some clearing of the rows. We're going to merge in some tetrominos. All right, we've got a few things left to do, and the next thing we're going to do is to actually make this tetramino merge here and create a new tetramino to fall down. And then we're also going to sweep the rows if we have cleared any rows here. So move inside of the useStage hook. And first we can try one thing here in the update stage function, just above the return new stage. We're going to have an if statement, if player.collided. We're going to reset the player. And this is also why we need that reset player inside of this hook. So save and go back to the game. And you can see now when we collide here that we actually are getting a new tetramino, but we won't be able to clear any rows. You can see that it just stays, and that's no good. So we need to take into consideration that we actually want to clear some rows also. All right, so that's what we're going to do. So move back to the useStage hook, and here, instead of just resetting the player, we're going to have a little function that also checks if we have cleared some rows. So return sweep rows, and we give it the new stage, and we're going to create this function here. We can do it up here inside of useFact, but we also need a new state, const rows cleared, and set rows cleared equal useState, and we start at 0, and we need to specify it as react.useState. Right, so here the first thing we do here is to set rows cleared 0, so that we always start at 0. Then we have a function called const sweep rows. We're going to have the new stage. It's going to be of the type stage, and we're going to return a stage. And for this one, we're going to use a reduce. So new stage.reduce. Actually going to have a return statement also on this one. Return new stage.reduce. We have the accumulator, and we have the row. An arrow function, curly brackets, and we can do some stuff. If we don't find a 0, it means that the row is full and should be clear. So what I'm going to do now is I create an if statement row, and I'm going to run the find index method. We have the cell, and if the cell, the 0, the first value in the array, is equal to 0, so we check if this value is 0. If this one equal to -1, it means that we haven't found the 0, so that means that we need to clear the row, because this row is only containing cells from tetraminos. Then we set rows cleared. We have the previous and previous plus 1. Then we create an empty row at the beginning of the array to push the tetraminus down. Instead of returning a cleared row. So what we do here is that we place an empty row at the beginning of the array, and that will push all the tetraminus down, because when we clear a row, they should be pushed down. So ack.unshift, that will place it at the beginning of the array. We create a new array. useStage 0 length. We need the same length as we have on the stage. We fill it with a 0 and we set it to clear because this is a new row. And we can also say that it's as a stage cell array like that. And then we return the accumulator. And then we need to do some more stuff here because TypeScript complains. So otherwise we push the row and we return the accumulator. And here we need to specify the start array and set it as a stage, because this is in TypeScript, so this is what you have to do for TypeScript to work with the reduce. I have some small little arrow. Yeah, I think this one should be there. Should remove this one. So a little bit tricky here. So I'm going to go through it again. I run a reduce on the stage, the new stage that we're going to render. And I check this row here. If all the cells are not a 0, it means that this row should be cleared. It's only filled with tetraminus. So I set the rows cleared to 1. Then I'm going to create an empty row at the beginning of the array to push all the other rows down. So that's what I'm doing here with this unshift. And I create a cleared row with a 0 and clear. And then I return the accumulator. Otherwise, I push a row and I return the accumulator. So this will hopefully work. And I was implementing it here, I think. Yeah, save. Go back. And I may have an arrow. No, I start the game. So I have to play this here and see if I can get a row. Yeah, something like this, maybe. Yeah, let's see. Yeah, and it works. And this will be true even if we have 4 rows, so it will clear all of them if that's the case. So it's working. We only have left to do some row counting and score counting and stuff like that to display up here. Okay, let's implement some scoring and stuff, and then this game will be finished. At least in this tutorial, you can build on it and do whatever you want with it afterwards to make it even better. So let's move back inside of the code, and in the hooks folder, create a new file that's called useGameStatus.ts. And inside we import React from React. And then we also import row points from setup. And that's the one we had in the beginning here, as I talked about. When you clear 1 row, you get 40 in score, 2 rows 100, 3 rows 300, 4 rows 1200. And I think, if I remember correctly, that this is the original Tetris scoring system. All right, so back in the useGameStatus, we create a hook. Export const useGameStatus. It will take in the rows cleared. It's going to be a number. And we're going to have 3 states here: const, score, and set score. It's going to be a react.useStage. And it's going to be 0 to start with. Then we have the rows and set rows. It's going to be a React useState, and that's also going to be 0. Then we're going to have the level and set level. This one is going to be a React useState, but this one is going to start at 1. We start the level at 1. Then we have a React use effect. Just as with the useStage, we want to run this effect when certain things change. And in this case, it's going to be the rows cleared. If rows cleared is greater than 0, that's the only time we need to do something. So first, we set the score by the previous state and the previous plus row points and rows cleared -1 times the level. And this is how the original Tetris score is calculated, if I remember correctly. Then we set the rows previous and previous plus rows cleared. Something like that. And then we're going to have a dependency array for this use effect. And it's going to be dependent on rows cleared. And that's everything that we need in this hook. We need to return something also. So we return the score, the set score, the rows, set rows, the level, and set level. It should say rows up there, not row. Some auto formatting, save this hook and go inside of the app component. And we're going to do the last stuff now in this game. So here we're going to import useGameStatus from /hooks useGameStatus. Just below the other hooks here, we have a const. The structure out the score, set score, rows, set rows, level, and set level. And we're going to call the useGameStatus, and it needs the rows cleared. And these ones, we can destructure out now from the useStage hook, because we have that state inside of there, hopefully. Yeah, I haven't added it here in the export. Rows cleared, like that. And rows cleared, so we send that one in to the useGameStatus. All right. So we have everything we need now to assemble this game, to have some scoring. So here in the handle start game, we can do some resetting here also. Set score to 0. Set level to 1. Set rows to 0. And I think that's going to be everything in the start game function. We can also add in some score and rows and level down here in the JSX. So we have a $, and we have the score. Here we have a $, and the rows, and the $, and the level. All right, what more do we have to do here? In the drop function, we need to do some stuff also, because we want to change the level depending on the score. So increase level when player has cleared 10 rows. And of course, this 10 is also something that you can put in the setup. Instead, I'm going to hard code it in here now. Instead of just typing it out here now, if rows is equal to level times 10, we need to take into account the level, because next time it's going to change when the rows is 20, 30, 40, 50, and so on, 60, 70, 80, 90, 100. Yeah. So you get what I'm trying to do here, hopefully. So then we set the level. We have the previous level, and we add a level, previous +1. Also increase speed. Set drop time we control the speed with the drop time. 1000 divided by level plus 200. Also some arbitrary values that I've tried that I think works. So this will increase the level and increase the drop time. I think we have to do also in the key up. Yeah, because we just set it to 1000 now. I think, yeah, so we have to this here. We also have to take into consideration here in the key up like this, so that we get the correct speed that we had before. We also take into consideration the game over here, if not game over, so that we won't run this when we're in game over. And we also have to do that here. If not game over, we don't want to activate the key presses when we're in game over. And I think this should be it. I think we may have finished this game. Let's try it out. Yeah, I don't know why the background will flicker a little bit when we collide. It must be something with Vite on how it builds the package here. I haven't experienced this before, so it can just be a temporary thing now. I don't know really, to be honest. The game seems to be working at least. It's not consistent. It's not on every render. Yeah, there I got 3 rows and I got score 300 and level is still 1. Yeah, that was a bad move. Oh, not good, not good. Yeah, that's better. Yeah, boom. And it seems to calculate the score correctly. Let's see if the level increase. And it does, so it works. Super great. All right, this is a basic Tetris game in React with hooks. I hope you enjoy this one, and as always, if you like my stuff, please subscribe to my channel and spread the word. I need the help. I need my channel to grow, and I love doing this stuff. But I need my channel to grow for me to be able to do this more. So, hope you learned something in React. And as I said, this is not to create the most perfect Tetris game. It is merely done because I want to teach React stuff in different ways. So you can make games in React like this and get it to work. But I'm not saying that it's the most optimal way of creating a game like this. All right. So hopefully see you in another one.